EVS question 2, present and report. The first EVS question we have is question A. This question asks us to reproduce the estimates of the equation on page 369, which is equation 9.59, and that is an estimated equation for Oken's law. Now, to be able to do that, we need to open up EViews. Once we've got that open, we need to click on Open an existing EViews work file to be able to import the file we're looking for. Step 2 is to start to reproduce the estimate. So we will need to put in a series formula in the command window. You will notice that once that's been put into the command window and we've pressed enter, that DU will appear in your work file. The next step is to create the equation, and we'll be able to do that by clicking on Object, New Object, and then the equation estimation window will open. We will enter the following equation of du brackets -1, close brackets, g space g brackets -1, close brackets, and c. Once we've entered this equation, we can click on OK. Once we've clicked OK in EViews, the following screen will appear. You will see that we've been able to reproduce the estimates. If we go through them one by one, you'll see that they all match up according to what was required through the question. The next question is question B. What we need to do is check the parallelogram of the residuals and also determine if there are any significant autocorrelations. Now, why do we want to do this test? You would have noticed in our previous question that we've used a data file called Oken. Now, Oken's law is an observed relationship between unemployment and losses in a country's production. It states that for every 1% increase in the unemployment rate, a country's GDP will be roughly an additional 2% lower than its potential GDP. The country that we're using in the data is the US. We are therefore trying to estimate GDP as a function of the change in unemployment as per Oken's law. The variable of interest here is GDP. So the question we are dealing with is there a problem? How are things going in terms of serial correlation? What we can do is actually look at the parallelogram of the residuals and see if there are any issues there. When we open up EViews with the equation we've done before, all we need to do is click on View, Residual Diagnostics, and then Parallelogram, and make sure that it's the Q statistics one, not the squared residuals. Next, we enter the amount of lags. In this case, we will enter 36. And then we click on OK. Once we've clicked on OK, we are able to see the output of that file. So let's have a look at this parallelogram. So at the top, you will see the autocorrelation. The bars indicate if the numbers are significant enough. Now basically, if we can't see the bars on the side, then those lags are significant. If we look at the lags, then all of them seem to be insignificant, except for one that is close to the third lag, and that's close to one of the bars, but it's still not significant enough. We are therefore dealing with no significant correlations, and therefore there isn't a problem of autocorrelation. No autocorrelation refers to the situation where there is no identifiable relationship between the values of the error term. Moving on to question C. What we need to do here is carry out an LM test for autocorrelation on the residuals and also determine if there are any significant autocorrelations. So what we will do is we will open up EViews. We'll go to our equation and then go View, Residual Diagnostics, Serial Correlation, LM test. That will ask us again to enter lags. In this case, we are required to enter 4, and we will click OK. Once we've clicked on OK, the following screen appears. The same question we can ask as before is, why do we do this test? The LM test is an alternative to the Q statistics test we've done earlier for testing serial correlation. The null hypothesis of the LM test is that there is no serial correlation up to the lag order identified. In this case, it was 4. The serial correlation LM test results for this equation with 4 lags do not therefore reject the null hypothesis. If we specifically look at the probability chi-square result, it indicates that the data is not statistically significant.